So far this chapter, we have looked at simple interest. Today, we are going to look at a concept called compound interest. So what compound interest is it's interest on a loan or a deposit that's calculated based on both the initial principal and the accumulated interest from the previous period. Okay, so what does compound interest look like? So let's say you borrowed $1,000 and your interest rate was 10%. Okay, your new principal would be $1,100. Your next year loan, the interest would be calculated using the new principal. Okay, so I know that's confusing, but let's look how this is different from simple interest. Okay, so when we're doing simple interest, in this example, P would equal 1,000, R would equal 10%. And again, remember, we would have to write that as 0.10. And our term is 3 years. Okay. If we were looking at simple interest, for the first year, our loan was $1,000. We took the interest, multiplied it by the rate, which was 100. And for the first year, it's only 1. This is our new principal. Okay, so when we're doing this with simple interest, notice that all of these stayed 1,000. Okay, but if we were looking at compound interest, I would then take this number and that would be my new principal. Okay, so then I would take that number, the 1,110, and multiply it by 10%. This is now $110. So my loan at the end is $1,210. Now the next year, year 3, that becomes my new principal. Okay, so then this number becomes 1,210 times 10%. So my interest is $121. And then this becomes $1,331. Okay, so look at how that's different from simple interest. Simple interest, my loan start was always $1,000. Okay, but when I'm doing compound interest, my principal is going to change based on what the new principal is at the end of that year. And again, this is with no deposits or withdrawals made within those 3 years. Okay. So for this one, my principal was always changing. First it was $1,000, then it was $1,100, then it was $1,210. My interest was always 10%, and then my loan at the end was $1,331. Okay, now this would be a lot of work if I had to go through, like say this was a compound interest loan for 10 years, having to go through and do this for 10 years, well, that would take forever, right? So we do have a formula, okay? And it looks like this. This is our compound interest formula. And this is where we were telling you guys at the beginning of the chapter, it is going to be way, way easier to use this formula on a graphing calculator than any other calculator you have out there. So if you have a way to have a graphing calculator for this section, you're definitely going to want to use it. Okay, so what do all these letters mean in this formula? So first, A is the amount of money you owe at the end of the loan. So remember, we also called that the maturity value. We can also call it the ending balance. Okay, that is A. P is still the principal. R is still the rate. and t is still the time. So those three variables did not change. But we do have a new variable, which is n, and n is the number of times in a year that the loan compounds. Okay, so that's a new concept for us. But I do have these typed out for you guys so you know what it means when it's talking about these in the different problems. If it says that the loan is compounded annually, then for n you plug in 1. If it's compounded semi-annually, that means twice a year, so n is equal to 2. Quarterly means 4 times a year. Monthly is 12 times a year, right? Because there's 12 months in a year. Semi-monthly is 24 because it's 2 times in each month. Bi-weekly is 26, weekly is 52, and daily is 365. Okay, so we used these numbers when we were talking about paychecks previously, so they're not new, but in this case, n means the amount of times that your loan is compounded per year. Okay, so if I just scroll up to this example just to look at this again, this loan was compounded once each year. So that's why year 1 we did it once, year 2 we did it twice, year 3 we did it 3 times. Okay, but we don't have to do all those steps now that we know our simple interest formula. All right, so let's try an example. It says you borrow $1,000 to start a chicken business. The bank approves a loan with an 8% interest rate for 3 years. All right, so let's figure out what our interest or our principal, our rate, our time, and our n is. All right, so our principal would be $1,000. All right, our rate is going to be 8%, which we have to change to 0.08. Our T would be 3 years. Which we found right here. And then n in this case would be 1 because it didn't specify any differently. Okay, now I did retype our formula over here so we don't have to keep scrolling up and down. But A is equal to the principal times 1 plus R over N. So that is going to be 0.08 over 1. And then our exponent over there is n times t. So in this case, it's going to be 1 times 3. Okay, now if you have a graphing calculator, you can type it in your calculator exactly like this. So follow along. I'm going to type 1,000 parenthesis 1 plus, and then remember I can hit alpha, y equals, enter to get a fraction, and I can type 0.08 over 1, and then our exponent key in our calculator looks like this. It's right on top of the division sign. So I'm going to hit that caret key, and then I'm going to do 1 times 3. All right, and when I do that, I get $1,259.71. Now, if you don't have a graphing calculator, you're probably going to have to do this in a couple steps, okay? The first thing you're going to have to do is figure out what this number is going to be, which this one isn't too bad because it's over 1. So I would have 1,000 times 1 plus 0.08 to the third power. And that may be a little bit easier to type in a calculator that's not a graphing calculator. It's going to get a little bit more interesting when that number is not a 1. But of course, if you're getting different numbers in your calculator, just call one of us over there to help you. Okay. And then we have a couple question here. It says you sell the grown chickens for $1,600. What is your profit? Well, $1,259.71 is how much money you're paying back on that loan. So if you're selling the chickens for $1,600, all you have to do is subtract the amount that you're having to pay for those chickens, and then all the money that you're making after that is profit, right? After you pay off the loan, the extra money is your profit. So in this case, it's going to be $340.29. All right, now here's an interesting question. It says, what if you sold the chickens for $900? Well, let's see. You know that you still have to pay the bank $1,259.71, right? That's how much money you have to pay the bank back on your loan. So if I take that number and subtract 900 from it, I get $359.71. So basically, if you only sell the chickens for $900, then your company is actually losing money each month, and you're losing $359.71 per month. All right, so that's why it's important that you're selling the chickens for enough money to make a profit, or else you're probably going to go out of business, okay? Like in the second example, when you're only selling them for $600. Okay, let's look at another one. All right, so to find how much interest you will be paying on a loan, forgot a T there, you will take the total amount of money owed and subtract your principal. So this is very similar to what we did with simple interest, but I did type out this formula. So if it's just asking how much interest you paid, you're taking your A, which remember all the way up at the top, that's the amount that you owe after the interest, and you're subtracting the original principal. Okay, so let's try one of these. It says Brenda invests $4,848 in her brother's new flooring company. Her brother loans has a fixed annual interest rate of 5%, compounded semi-annually. What will the account balance be after 6 years? All right, so reading through the problem, here is our principal. Okay, our interest rate was 5%, but remember we're going to use 0.05. Our time is 6 years. And then it says compounded semi-annually. So remember we had all those typed up, and semi-annually means 2 times per year. All right, so in this case, n is going to equal 2. Okay, so now we're going to plug those numbers into our simple interest formula. So our principal, $4,848 times 1 plus our rate, 0.05 over n, which is 2, to the exponent n times t. All right, now again, if you have a graphing calculator, you can type it in your calculator just like this. 4848 times 1 plus, and then you can hit alpha, y equals enter, 0.05 divided by 2. And then remember your exponent button looks like this. It's right over the division sign on the right side of your calculator. And then you can just do 2 times 6 and make sure both of those stay up in the exponent. All right, and when I did that, I got A to equal $6,520.02. Now, again, if you don't have a graphing calculator, you may have to take a couple more steps here. So I would have 48 times 1 plus, I'm going to do 0.05 divided by 2 in my calculator. And I get 0.25. And then my exponent's going to be 12. All right, so when I'm typing this in my calculator, I would then probably do this. 1 plus 0.25 is 1.25 to the second power, or 12th power. So then I would just take the 1.1 or 1.25 to the 12th power. And then I get 48 times 14.55. Multiply those together. And I should get about the same thing, which I'm realizing I forgot a 0 here. This is why this way can be a little bit more tricky, because it's easier to make mistakes, unfortunately. So then that number is going to be smaller. So 1.1025 to the 12th power is actually 1.34, and then multiply that by 48. There we go. Then I got my $6,520.02. Okay, so if you have a graphing calculator, you can ignore all that writing in the black. You can just look at the pink part. But if you don't have a graphing calculator, it's just going to take a little bit longer, because you're going to have to do order of operations and all that kind of stuff. Okay, so then it says how much interest is paid. So that was this new formula that I gave you up here. So I is going to be equal to A, which we just found to be $6,520.02. And we're going to subtract our original principal from that. So, holy cow, how much did we pay in interest? $1,672.02. And remember, money is always rounded to 2 decimal places. All right, let's try another one. It says Sarah invests $21,000 into a company which a loan having a 13.6% interest rate is compounded quarterly for 4 years. What is the balance? So our principal is going to be $21,000. Our rate is 13.6%. But remember, if I take that and divide it by 100, I get that to be 0.136. Our T is 4 years. And compounded quarterly, if you don't remember, quarterly would be 4 times per year, so our N is going to be 4. All right, and let's plug that into our formula. Oops, actually write what the principal is. 21,000 times 1 plus 0.136 divided by N, which is 4. And we're going to raise that to N times T. So that's going to be 4 times 4. All right, so type that in your graphing calculator. 21,000 parenthesis 1 plus alpha y, enter, 0.136 over 4, parenthesis, Again, use that little caret key and do 4 times 4. And I got $35,854.85. Okay, so again, for your non-graphing calculator people, tune me out if you have a graphing calculator. I'm going to do 21,000, and then I'm going to figure out what's in the parentheses. So this is going to be 1 plus, and then on my calculator, I'm going to type 0.136 divided by 4. And I get 0.034 to the 16th power. So that's going to be 21,000. And then 1 plus 0.034 is just going to be 1.034 to the 16th power. All right, so please excuse my dear Aunt Sally, you have to get rid of the parentheses first. So I'm taking 1.034 and taking that to the 16th power. And I get 21,000 times 1.71. Multiply those together and you should get something very close to what we got over here. And I did, I got $35,854.85. Okay, so you should get the same thing. Again, if you don't have a graphing calculator, it's just going to take a few more steps. So how much interest did we pay? Well, I'm going to take A, which is $35,854.85, and subtract my principal. And holy cow, you are paying $14,854.85. So this is why it's always better to pay off a loan as fast as you can, because the more money you're borrowing at a higher interest rate, right, the more interest you're going to be paying. That is a lot of money to pay for borrowing money. All right, so that is how we're going to do compound interest. Again, if you're struggling with your calculator because you don't have a graphing calculator, please make sure you call one of us over to help you figure that out.